In these next couple of videos, we're just going to get some practice creating confidence intervals for means. So you can take a look at the step-by-step process outlined above. That's going to be what I'm roughly following here. Let's have a look at our example. It says, in a recent sample of 84 used car sales costs, the sample mean was $6,425 with a standard deviation of $3,156. We would like to construct and interpret a 99% confidence interval for the mean cost of a used car. So the first thing that I want to do is just do some information gathering, lay out what we know. In particular, the things that we're certainly going to need. We want to know what is X bar, our sample mean, what is S, our sample standard deviation, and what is N, our sample size. So this says our sample mean was $6,425. Our standard deviation was $3,156. And our sample size, we looked at 84 costs. So we're looking at 84 used car sales costs. So we've got all of our information. That's good. That's all we really need to do here in this first step is make sure we've got everything that we need. Step 2 is really just making sure that our conditions are met. We need one of two things to be true if we're going to use the central limit theorem. We either need n to be greater than or equal to 30, or we need the population that we're choosing from to be normal. Population is normal. We only really use that second if n is not greater than or equal to 30. However, n is equal to 84. That's certainly greater than or equal to 30. So yes, we get to use the central limit theorem. We have verified our conditions here. So that's great. That means that we can actually go and build the confidence interval, because if we didn't have those conditions, it doesn't really make sense to. Everything we do relies on the central limit theorem, and if we don't have that, nothing we do after this point would be accurate. So step 3, we're actually going to go and start to find some of these values. Before I actually start doing my calculation, I am going to need to know my degrees of freedom, because we're going to have to go and find our T star, our critical T star, like we saw in a couple of videos ago. So remember, degrees of freedom is n minus 1. So in this case, 84 minus 1 would give me 83. So my degrees of freedom in this case are 83. I'm also going to need to think about what the two-tail area is. Remember, I need to know what that looks like. When I go and I construct my confidence interval, I know I want my confidence level, which in this case is 99%, to be the area right here in the middle, which means that I want the area in two tails, in both the left and the right tail, to be 1 minus my confidence level, 1 minus 0.99 to get 0.01. So I want a two-tail area of 0.01 with 83 degrees of freedom. So that should be enough information to help me go and find my T star. So let's hop over to our T table real quick. So looking at my T table, we said 83 degrees of freedom. And if I scroll down 83, well, that should be somewhere between 80 and 90. I don't have that here. So remember, when we're talking about degrees of freedom, we always go down, regardless of how that number would normally round. So in this case, we're looking at 80 degrees of freedom. This is the column that we're looking at. And then we set a two-tail area of 0.01. So a two-tail area of 0.01, that would mean we're looking at this far column over here. This is what we want. We, of course, want the overlap between those two, so our critical T star will be 2.64. So let me make a note of that here, my T star in this problem. So T star is equal to 2.64. And after that, I've got everything I need now. Just like I did in the confidence intervals for proportions, I'm going to start off by finding my standard error, which I actually think in this case is a little bit easier. It's S, my standard deviation, divided by square root of n, my sample size. So in this case, it's going to be 3,156 divided by square root of 84. So let's see, 3156 divided by the square root of 84. I ended up with 344.348. I like to generally round to 3 decimal places unless I need more precision. I think 3 will be just fine for us here. So there's my standard error. Next up, I need my margin of error, which my margin of error is T star, that number that we just found right here in red, times my standard error. Well, that's the number that I just calculated, 344. So times my standard error. So T star we said is 2.64 times 344.348. Let me grab my calculator real quick. Times 344.348. And here I get 909.079 as my margin of error. And then lastly, finally, I would like to actually go and build my confidence interval. So to actually go and do that, my confidence interval always looks the same. The general form that we follow is we start with our point estimate, which in this case we're trying to estimate the population mean. So our point estimate will be our average mean, x bar, plus or minus whatever our margin of error is, and that is the number that we just found over here. So our sample mean x bar is $6,425. $6,425 plus or minus m, that would be 909.079. So I really have 2 numbers here. Remember, I'm adding this and I'm subtracting this. So this really says 6,425 minus 909.079. And then for my upper bound, $6,425 plus 909.079. So let me grab my calculator real quick. Minus 909.079. My lower bound should look like 5,515.921. And then my upper bound, when I add those 2 values together, 909.079, I end up with 7,334.079. Now remember, we're talking about dollars and cents, so it might make more sense, cents pun, it might make more sense to round this to 2 decimal places instead of 3. I'm going to leave it as it is. Obviously, just make sure you read the directions carefully for how many decimal places this is asking for. So there's my third step, the result of it. There's the actual construction of that confidence interval. So I have one last step remaining. My fourth and final step is just to write a brief little summary talking about what that confidence interval actually means. What is it telling us? So remember, we always want to start off by talking about our confidence level. So we said, I believe we were doing, yes, a 99% confidence interval. So we are looking for 99% confidence. So I'm going to start by saying we are 99% confident that and at this point we want to make sure we mention what it is that we're actually trying to estimate here. We're trying to talk about population average or population mean. So we want to say the average or the mean. Either case, we'll use the mean. We'll use the same language that our problem used. The mean cost of a used car. And this is trying to estimate the mean cost of all used cars together. So remember, we're trying to identify a population and identify the mean of that population. So the mean cost of a used car is between, we said, $5,515.921 and $7,334.079. So the overall interpretation should feel pretty familiar to the interpretations that we looked at way back in chapter 5 and 6 when we were talking about confidence intervals for proportions. Just the one key difference that we want to make sure that we mention here is that we're talking about means instead of averages. So we want to make sure that we mention that somewhere within our interpretation.